Video for experiment 4, chemical changes in air pollution. There will be several videos of me actually doing the experiment, and from those videos you can gather the data. So in this experiment, I'm probably not going to provide you with very much data because you can look at the videos and come up with them. Some of them are a little hard to see, but I can help you with those as well. But I'm going to give you a lot of the equations that you have to write. So air pollution, there's a lot of things that cause air pollution. You know, there's things like particulates. If you look over here on the left, there's particulate matter, which is dust and stuff that gets blown up, or even some other things. Fertilizers, things like that. Wind, you know, even just smoke and stuff like that. And then a lot of pollution is actually produced by combustion. And as a society, we burn a lot of stuff for sources of energy. So this lab is really going to focus more on that. And so in part A, we're going to look at combustion of fossil fuels. So fossil fuels are fuels that come out of the ground. All right, so there's a couple of major types. There's coal, which we'll talk about a little bit later. That's activity 2. And then there's methane, natural gas, which is activity 1. So let's just kind of go through each activity. I've included the background and this document on the left and the procedures for reference, although you don't really need to do much with the procedure, and then there will of course be a data sheet. All right, so if we look at combustion, combustion means combines with oxygen. And so in general, you have whatever you're burning plus oxygen, excuse the writing, that's going to give you XaOB, whatever ratio, but it kind of depends. In the case of a hydrocarbon, hydrocarbons, we do a lot of combustion hydrocarbons, and again, you should have some support from lecture, but just, you know, never hurts to hear something twice. Hydrocarbons are CXHY. It's an X and a Y. So when you burn a hydrocarbon, you always, burning means plus oxygen, you will always get carbon dioxide and water vapor. Now that assumes that you burn it completely, and that depends on the ratio of the hydrocarbon to oxygen. So in your burning process, if you don't have enough oxygen, this reaction won't go to completion, and you can get other products. So from incomplete combustion, you can get unburned carbon, you can get carbon monoxide, you can get shorter chains, so let's say CXHY, but lower X's and Y's. So if this is an 8, this might be a 3. So you get all sorts of stuff, and so we're going to look at that. So in the first activity, let me clear this. Okay, in activity 1, I'll just do it this way. Activity 1, we're going to look at a Bunsen burner. And I broke this into 2 parts, so I just showed you me doing it, and then I have the results. So what we did in activity 1 is we take a Bunsen burner, and a Bunsen burner burns. So the equation is methane, and you can see it over to the left. This is methane. And then plus oxygen. And that's going to give you, of course, carbon dioxide and water vapor, and you need to balance the equation, and you'll be asked to do that. But what we do with this first is I take a Bunsen burner and I adjust the ratio so that we have the appropriate amount of oxygen, and then I held an evaporating dish up to it. An evaporating dish is just a ceramic dish, and let it sit there for several minutes, and you'll see what it looks like. Then what I did is I have another one where I covered up the oxygen so there's less oxygen. So in a Bunsen burner, when you're burning it, and even in your home, if you have gas heating, the flame should be blue. That's if there's enough oxygen. If the flame is yellow, that means you don't have enough oxygen, and that's because there's going to be unburned carbon in there. And if you have a yellow flame, it produces some of those other things, one of which is carbon. And so at the second half of the Activity 1 video, part 2, you can see the an evaporating dish that I covered up the holes on the Bunsen burner, and you'll see that it looks a little bit discolored. All right, moving to activity 2. This one, the video didn't come out as nice as I would like, but activity 2, whoops. Activity 2, wow, I've made it smaller, that's cool. Huh. Let's fix that, let's make it a little bit bigger. It's just burning coal. And coal has a very complex formula, but just think of it as burning, for burning coal. So I'm looking at this. And you'll see a coal looks like just a big black rock. And what I did is I didn't follow the procedure exactly. I just stuck it in a Bunsen burner. And if you look carefully, you can see some smoke coming off of it once I get the thing lit. And so coal's a very dirty fuel. It contains carbon, it contains sulfur, it's got all sorts of stuff in there. But you're just going to look at what happened when I burned it. All right. Also, when I made the video, I misspoke. I think I called it activity 3, but then I said in the activity 3 video, I told you, oops, I screwed up. It's actually activity 2. All right, but you'll see it. Okay, activity 3 is just crude oil, and you're just going to look at it. So crude oil, when oil is taken out of the ground, that's what it looks like, and you're just asked to look at it, and I hold it up for you. All right, so then with the next activities get a little bit more interesting. All right, so let's go back to this. All right, so now we're going to go to activity 4. And activity 4 has a part 1 and a part 2. So in activity 4, we have burning octane, and you'll just see the result. So octane is C8H18. And that is a major component of gasoline. And then you're going to burn it. And if it burns completely, you get carbon dioxide and water vapor. And you can do the balanced chemical equation. What you're going to see is I just basically poured some in an evaporating dish and I let it burn. And then part 2, I show you what it looks like at the end, right? And so that's pretty much all you need for that activity. Now, the next one is activity 5. Activity 5 is a little bit more interesting, all right? Activity 5, we're going to burn sulfur. So that's a 5 there. So we're going to burn sulfur. And so when sulfur burns, it can actually form SO2 and SO3, but typically it forms SO2. All right. Now, what's interesting about this, and this is again over on the left-hand side here, all right, what I do is I burn some sulfur, but then what I do is I capture the smoke. Now, the smoke is what's called a non-metal oxide. So sulfur is a non-metal. You can get that from your periodic table. When you burn anything, when you combine things with oxygen, you get an oxide. And that's a general term. If this is a non-metal, that's a non-metal oxide. This is also a non-metal oxide. So the sulfur dioxide is a non-metal oxide. Non-metal oxides can react with water, and they can form what are called acids. And so what I do in this video is I collect the smoke, and then I have some water in a container where I collect the smoke, and I swirl it around, and it's going to form this. Now, all acids, this is called sulfurous acid. We're not going to get into acid naming, but all acids in general, acids formula are going to be H something, except for, of course, water. Now, an interesting property of acids is acids react with bases. Now, what a base does, we'll do acid-base chemistry later, but we're going to use a chemical indicator, and we're going to use a base. So sodium hydroxide, I'm going to clear this screen here, and then we'll continue with this. So this is still activity 5. Okay, so remember we had S plus O2 makes SO2, and we have SO2 plus H2O makes H2SO3. Now, how are we proving that we made that compound? What we're doing is I take a flask and I put some sodium hydroxide in it. Sodium hydroxide is a compound that's called a base, also called alkali. That says base. Okay, and acids react with bases. Now, what we do is we're going to use what's called a chemical indicator. You saw me use pH paper in experiment 1. Okay, chemical indicator, just something that turns color in the presence of chemicals, and it depends on the chemical and what color it's going to turn. In this case, the indicator is phenolphthalein. Phenolphthalein, in the presence of base, it's pink, bright pink. And in the presence of acid or neutral, it is colorless. So what I do in this particular thing is I take a flask that's got some sodium hydroxide in there and phenolphthalein, so it looks pink. And then I make this, I take the sulfur and I burn it and I capture the smoke. And what happens, what you'll see is if I form this, H2SO3, and the reaction is given to the left over here on the document, I will form and you can balance this, Na2SO3 and water. And of course, what happens is this is not pink. And so what that shows is that something, it's only pink because there's sodium hydroxide there. So that shows something reacted with the sodium hydroxide, but that shows that we get this. Now, why is that relevant to pollution? Well, this is shot up into the air anytime sulfur is burned, and sulfur is very common in fossil fuels, mixes with water in the air. That is an example of acid rain. All right, and then the last part, what we're going to do, so that's activity 5. The last one is really a simulation. We can't make nitrogen dioxide. So activity 6, and that's because it's nasty. We could, but it's really a toxic gas. So activity 6 is we're going to simulate nitrogen. Now what happens with nitrogen is, especially in a car, air is 78% nitrogen. And so burning, when you pull air into a very hot thing like the temperature of your engine, you can actually burn the nitrogen. Nitrogen is extremely unreactive, but in the temperature of an internal combustion engine, you can form, they're actually called NOx's. So you can get N2, various ratios of nitrogen to oxygen. So N2 plus O2 going to NO, N2 plus O2 going to NO2. NO2 is a brown gas. So if you look out on a smoggy day, that's a big, especially like in LA. Now what we're going to do instead is we're going to make something that actually has that color. And if you look over here, these are the reactions we're going to do. I'm going to take, I'm going to take iron 3 nitrate and I'm going to do this reaction over here. I'm going to take basically the iron 3 ion, the iron 2 ion plus nitrate ion. And then I'm going to drip some acid in there. So I'm actually taking, this is the reaction. You can see it actually over there. It's going to give me plus NO plus H2O. But then what happens is at the excess, this plus the NO gas is going to give me something that has the color. This is called a complex ion, and you will deal with that in a much higher chemistry class. Whoops. You can see it better over to the left. Okay, and this has the color, and you can see what it looks like. Kind of forms a kind of a brownish green color. All right, so that is the background material for experiment 4. Whoops, experiment 4. And I think you have enough to do it. And of course the videos. And remember, videos, you can hit the pause button. That's it for experiment 4, and I think you should be good to go.